Okay, I'm back.
Okay, if you're seeing my screen, got a lot here you potentially covered. Looks like interestingly, looks like they've omitted some arrows here, which makes a small difference. Name each of the following segment A, B. So they're referring to the part that just cuts through the circle but doesn't go through the center. That is a chord. A
Mhm.
chord does not go through the center. Now, line AB, it's the chord, but it also extends past in each direction,
That's the
and that
segment,
is,
right?
well, it's called a secant. When it cuts
Oh,
through. I mean, this is vocabulary. I wouldn't say this is super important to know long term, but in the class you need this information.
mhm.
Segment C to G. Okay, that's a G there. That's a radius. It goes from the center out to the edge of the circle. Okay.
Mhm.
And then F to C, which is not drawn. Is that right? You think that's right? Because it sure doesn't seem, I mean, it's another line here.
Yeah, I think that's just the diameter.
It would be if it goes through the center. Since
Oh,
it does not go through the center, we cannot say that. It makes the most sense though that it would be. So maybe instructor Matt IC might check that because it would be odd to have a duplication in something like this. But you're right,
mhm.
like I to C would be a diameter, F to C is chord. Point G is the center there.
Mhm.
So not quite sure what to say to do there. It's either chord or diameter, depending on what the right letter is.
Okay.
Okay. All right, let's move on to number 2.
Oh wait, I already got number 2.
Okay. Do you want me to check your answer or do you want to just go with what you
I
got?
Yeah, sure, you could check it. I got 6.63.
Okay, so you're not supposed to reduce the root here. You're allowed to use a calculator.
Yeah, we're allowed.
Okay. The preferred answer, I think, is the square root of 44, which is 2 square root of 11, which is exactly what you said, but it,
Oh.
you know, some teachers like, yeah, sure, no problem. End of the year, what you want. Some are like, nope, we're gonna go back to the same stuff from the beginning of the year. Up to
Mhm.
you. Happy to clarify that, but we can also just move on to number 3.
Yeah.
Okay, to write the equation of a circle, that has to be given here. Let me do that off the right. So it's x minus h squared plus y minus k squared equals r squared. This is h, this is k, and this is r.
Whoa.
So, so it looks like maybe it's the first time you're seeing it or haven't seen it in a while. You've got to be comfortable with this and know that this is the radius. I'm sorry, the center is h before k. H goes with x. K goes with y. H comes before x in the alphabet, just like x comes before y in the alphabet.
Mhm.
All right. So to do this, you're putting those numbers into the formula there. It is x minus a minus 3 squared plus y minus 5 squared equals 12 squared, like that. So notice you're substituting in parentheses for the variables, especially when it's negative, because in the x here, you've got a little bit more to do. You have to realize, okay, 2 negatives make a positive. That's x plus 3 squared, like that. Plus y minus 5 squared equals 144. Is that okay?
Yeah, is that like the full equation?
That's everything.
Okay.
Happy to give you another example. Maybe we get through all this and then do that, but
Mhm.
do you think similar to this?
What?
Do you think your test will be similar to this?
Oh, yeah, for sure.
Okay. Yeah, it says review for retake, so I'm assuming they probably give you pretty similar questions.
Mhm.
All right, so H to J to I, H to J to I. It's a path. It's like saying, okay, start at H, go to J,
Would
and then come
I
back.
would I
Yeah,
do 180 plus 151
that.
minus and then do like 360 minus that?
Well, okay, so first thing you said is correct. 180 plus 151 is the measure of H to J to I, okay? If you
Mhm.
subtract that from 360, that is, and I'll show that in red here, that's this one.
Oh, okay.
You have to be careful just to make sure you're actually calculating the thing that you want to calculate, of course.
Okay.
So do you have a result for me there? 180 plus 151.
331.
Yeah, and you want to make sure you put the degree symbol in there. Some instructors are very picky, so they want it a certain way. So we should give it to them that way.
Okay.
The other way, I'll just point this out, the other way to find this part in red is to recognize that J to H is a diameter. And since this is 151, this little pizza slice, you add it up to get to 180, or you can subtract from 151 from 180 to get.
Oh, yeah.
So there's sometimes more than one way to do the same thing. So pick wisely. All right, find X. Find X. There's the math joke. There it is. But the X here is a radius, and there's many ways or an infinite number of radii in a circle. This is the one we want because it creates the triangle there.
Mhm.
That's that we can show kind of off to the side here if we want. 3.6, that's X. Now
Oh, so we
there's a
would just
theorem.
be finding the hypotenuse and 4 would be the one on top.
Yes.
Okay.
Good. And that's the other part of this theorem is that if it meets at a 90-degree angle, it's a it bisects in half. So you got to use the Pythagorean theorem there. You're welcome to use a calculator to do. These are the two legs. I'll confirm your result as well.
Okay. Okay, 1 second. Let me get my calculator.
Okay.
Okay, I'm gonna type it in.
All right. Sounds good.
Okay, I got 5.38.
I agree. X is 5.38.
Okay.
There's no units. Like if this had something in there like centimeters or something, we want to include that, but there are no units, so we have it. All right, so let me grab 6. All right, so when you see 6 here, sometimes you can say, okay, is this a reasonable assumption? What does angle D kind of look like?
A right
Is there,
angle.
yes. Now it is a right angle, and the reason it's a right angle is because this hypotenuse goes through the diameter, and there's a theorem that says if you grab two side lengths, it makes a right angle. But you're kind of in the part of the course where you can assume those kinds of things if it looks reasonable. So
Mhm.
Could you solve that for X for us, please?
Yes. $42.
Okay, so X is 42. That's great. Now, there's a couple of ways to proceed here. A lot of times you have to look at the circle without some of the lines in it, segments in it.
Mhm.
This 102 degrees has a relationship to this inscribed angle here. Do you remember that from earlier in the course or maybe recently?
I think
What the
so, yeah.
inscribed, what would that be?
Isn't that like 2, I mean, like 102 divided by 2?
Yes. So we have
Oh,
51
yay.
degrees there. And that corresponds to this one here. So a couple of options now, as you could add up all three angles to 180, or because it's a right triangle, these two angles, 51 and Y, they add up to 90.
Mhm.
So I would choose the latter. Oops. 51 plus Y equals 90. It's not 49, so just keep that in mind if you
It's 39.
it was 39. Y is 39 degrees.
Oh, weird. Okay.
Question on that?
I don't think so.
Okay. Let's keep going here. All right, find X or determine the value of X. So the important thing to remember is that all tangents
I also
from,
did this one.
oh, you did already. Okay, from the
Mhm.
same point are congruent. All right, what did you get for X then?
I got 3.
Okay, so the way to check here, 14 times 3, 42 minus 13 is 29. 3 times 8 is 24 plus 5 is
Mm.
29. So you got it. All
Yeah.
right, good job. Okay, next problem here. Okay, so we have to find the values of X and Y. The Gotta think about how to do this. So I don't want to proceed. If we redraw the circle with like this, for example, 104 degrees, that tells you that this is 208 degrees.
Mhm.
And then we can do something similar to find these other ones. No, that won't work. Or maybe that will work, but so the main one here is that 5x plus 2y equals 10 plus 104. The sum of your angles is 360. But the problem with that is we have one equation, two unknowns. That's not good. So
Mhm.
I'm trying to do something with these other angles to kind of help figure it out here. Now, if we draw the 110, that's what I'm trying to do here is try to figure out if there's a way to sort of piece this together. So that makes this 220, but there's an overlap there. So 220 is all of that. 208 is all of that. You can see there's an overlap there. There's something I'm not seeing here. Do you happen to remember anything from your class that allows you to it's either an inscribed angle or it's the consecutive angles, but I
I
don't
do
think
not remember this that well.
okay. Let me see here. I'm just gonna spend one other minute doing this. 5x becomes 10x. Okay, I think that's gonna give us the same equation though. 10x. Okay, so, okay, I guess I do see it now. It's kind of non-obvious, so let me draw it separately. If we look at what's in green here, corresponds to this, right? This all of this right here, and that's 208. Because the 104, that's what's trying to show over here, that 104 goes with the 208. It's an inscribed angle. Is that
Where
we
did you
just did
pull
that
the 208 from?
double the 104?
Oh, okay.
And it's an inscribed angle.
Oh, okay.
But notice it's missing this part in red. And that goes with the inscribed angle of 2y. So 2y doubled is 4y. And we know if we go all the way around a circle, that's 360 degrees. So the 208 plus the 4y equals 360. Now you could actually use the same sort of setup to find x, but we'll start with finding y here. So the main thing is, do you kind of see how that's that green? I'll draw it over here on the right. You know, that green goes with this one.
Mhm.
And then the missing one, I'll draw it over here in red. I need to just clear out a few things here. To draw the circle again. It's this is 2y and this is 4y, and the whole circle, you can see that these, and maybe that's what's maybe hard to see, is that they actually share the vertices. I don't really have a great color. They're right there, since they share those vertices. They're supposed to all be in the same place.
Mhm.
So in summary, you have to solve this first equation down here in the lower right for y. And then we'll use that value in the other equation to find x.
Okay. Let me do that really quick.
Okay.
Okay, I got 38.
Okay, so y equals 38. That's great. You can use that in the other equation now to find x.
X equals 14.
Right. So the next we probably, looking now ahead, 9 would have been a little bit easier to work with. It's a little more intuitive, but we don't have that at this point. So you're using the relationship that if you go all the way around a circle, it's 360 degrees. So all the way around the circle is a plus 100 plus 136 equals 360.
Mhm.
So could you use that relationship to
Let me work that out really quick. So A equals 124.
a equals 124? Good. And then there's a relationship between a and b. Few ways to look at it. A 2 times b is one way to look at it, or if you prefer the other way, it's okay. B is 1/2 of a. They are identical, meaning they produce the same result, but one may be more straightforward
B is 62.
I agree. And that is it.
Okay, wait, I'm gonna pause really second. I'll be right
Sure.
back.
Sure, sounds good.
Okay, I'm back.
All right, sounds good. Let's take a look at 10. We should be able to get through all of this. Okay, so one of the things that I think could help here is redrawing the circle and recognizing that 42 goes with X and then 2Y also goes with X. They share the same arc.
Mhm.
My drawings are not to scale, but you hopefully can see that. Yeah. Doing the best I can here. So to find X, it's the same as we've been doing. You either look at it as a doubling or dividing, depending on what you prefer.
Oh.
Um,
So X equals 84.
84 degrees. And then you can use that to find Y. But you have to be careful here because 2Y is half of X. Okay. And in other words, the two angles given are actually congruent. These are actually congruent. So if you take half of 84, that's 42. 2Y equals 42. Y equals 21.
Mhm.
Any questions on that?
No.
Okay. All right, so let's look at number 11. Find X. Okay, this one's slightly mislabeled. These all should be degrees. Unless, yeah, I mean, I think these are meant to be degrees. I don't know how this could work out, but all three of these are supposed to add up to 360.
Oh.
It's kind of like we were mentioning earlier, like if it looks like it should add up to something, just go with it at this point in the course. I mean, they're really, you can save yourself some frustration. So go ahead and solve that for us. Let me know what you come up with.
Okay. I got 53.67.
Four X, huh? 6X, 40. Did you get 6X plus 38 equals 360?
Yeah.
Okay. Did I write it down correctly? It just doesn't look right. You know, it's not that hard to make these numbers kind of work out nicely, and you just I'm always sort of looking out for that when we do these problems. So let me do 38. Yeah, okay. Well, you've got it. It's like you said, 53.7. 53.7. Okay. Moving along here. 12 is a different 12 starts a different kind of grouping of questions here. You're dealing with angles inside the circle, but this point right here where they meet is not the center.
Uh-huh.
And so there's a formula for this, which is if two chords meet not at the center, I call this little m, I call this arc big M, and x. X is little m plus big M divided by 2. Right. Now I know they use X, but what I'm trying to show you is that you average, you take the two arcs and add them together, divide it in 2, and that equals this inner angle. So in your
Oh.
problem, 32 is the kind of the inner angle here, and that equals 30 plus X divided by 2.
Oh, okay, I get that.
Okay, so you have to be comfortable solving something like this. You want to clear out the division by 2 first by multiplying everything by 2.
Mhm.
And that gives you 32 equals, I'm sorry, 64. I spoke there. 64 equals 30 plus X.
Okay, so x equals 34.
X does equal 34. Good. Okay. That's everything for that one. Let's look to 13. All right, so they're giving you a situation where the angle is now external to the circle.
Mhm.
Okay. And so whenever it's external, whether it's a secant or in this case a secant tangent, again, you'll see me use these letters X, little m, and big M. It's X equals now 1/2 big M minus little m. Order does matter. It's got to be the bigger one, take away the smaller. Now notice in your problem, you have the equivalent of big M here. You have the bigger arc, right? But
Mhm.
you don't have little m. So
So do
that's
we
not
divide
good.
it by 2?
We because we don't have this arc here, but we can find it. We can find that little piece right here because what do we know about the whole circle? If you go all the way around the circle,
It's 360.
360. So you can use that to solve for the piece of information 120, and I'll call that little m. Plus little m plus 154 equals 360.
M equals 86.
Okay. Now we can use that information in this formula here. 1/2 154 minus 86. And that gives you the value of X there.
Okay, 34.
34, that sounds correct. Yeah, X is 34. Okay. Any questions on that?
No.
Alright, so the next problem is very much related. It's actually the same formula, but you don't have the information you want. So I'll kind of draw it similar here. You got a tangent and a tangent. This is big M over here. This is little m over here, and this is x. X is again 1/2 big M minus little m. But you don't know M, you don't know big M or little m. But what you do have is this 135. This 135 is a central angle. That makes this other one 135 degrees. The arc there from A to C. Because it's a central angle. How can we find the other arc?
We do 360 minus 135.
Exactly.
Uh, 225.
225, very good. So now you have it. You have 225, you have 135. So X is 225 minus 135. Got that in now.
$45.
Okay. Now, unfortunately, that is not the answer though, because that is 5x. So the X we just solved for is the X here. That is the same as the 5x.
Oh,
They're adding just a tiny bit of like extra steps here that could be, it's easy to probably write the wrong answer.
9.
X is 9. So the actual value of X is 9. Now we have it. All right, if that's clear, that's great.
Yeah.
We should actually we're going to do 17 and 18 first, and then we'll come back to the other two. We'll get them all done, but these kind of fall more in line with what we've been doing. Hopefully that's okay.
Yeah.
All right, so find the area of the shaded sector. What I can't tell from my screen is the shaded part, the one up here.
I can't tell either, but let's assume, yeah.
Okay. So it's this one up here. The area of a circle is pi r squared. Okay, you've probably known that for a long time. The area of a sector is also pi r squared, but it has an angle out of 360 in front of it because it's a pizza slice, maybe a big pizza slice, but it's some angle that represents a fraction of the circle.
Mhm.
Right? So you have to sit here and say, okay, what is that angle? What's the fraction of that circle? Well, it's 160 out of 360 because that's the central angle. Think of theta right here as the central angle.
Mhm.
Right? And so pi radius is 7 squared. You're welcome to put this in a calculator, or you can do it exactly. Although I don't know how exact this one works out, but when I say exact, you can put everything but the pi in the calculator. Sometimes it's a reasonable fraction or decimal.
Okay, I got 68.45.
And then units here. We finally have one with units. So 68.4-ish units feet squared. Right. Find the larger arc length. Okay, yeah, so 18 is related. All right, so in 18 here, they want the arc length. What they're asking for is the distance all the way around here. Like imagine you could walk all the way around the edge
Mhm.
of this. That is related to the circumference of a circle. The circumference of a circle is 2 pi r. And the length of a sector, so the sector length, is really similar. It's the angle out of 360 to pi r.
Mm.
So see how similar it is to the previous set of formulas? You have one
Yeah.
for area, one for sector, one for circumference, one for sector length. So if you were not given these, you could quickly do that. Now the central angle is 270. And the radius is 13. It is a unit of length again.
Jeez. Okay, I got 61.3 feet.
Right, I agree. And that's the length. That's like if someone said, hey, you're gonna walk from here, this point all the way around, that's what you're saying.
Okay.
Okay, so we will move on or move back to number 15. Okay, so before we can even write the equation of a circle, we need to know two things. We need to know where the center is, and we need to know the radius.
Mhm.
The center, the teacher's identifying right there. Could you give me those coordinates, please, for the center?
2, -1.
Good. Now to find the radius, you go from the center, and you can either go up or down or right or left. They should all be the same, and you're just counting.
So would the radius just be 4?
Looks like it's 4. Good. And now this is really, really similar to what we did on the other side of the paper, number 3. You notice number 3, it says write an equation with a center of -3, 5 and radius of 12. You have everything you need to do this. You have the value of h and k. You have the value of r. So will you give that a try, please, and put those into the equation here?
Yes. Okay, wait. Okay, I got x -2 squared plus y plus 1 squared equals 4 squared.
The second one that you said y plus 1 squared, and then it is 4 squared or 16, right?
Mhm.
Good. Okay. That's great.
So that's it? That's like the final form?
Yep.
That's so weird.
Got it. Yeah. All right. Well, 16 is maybe the most difficult question on here. Requires you to complete the square, which most students don't remember, and for good reason. I mean, you never do this other than when you're in a math classroom.
Mhm.
But that is what's required here, unless you say, hey, you know what, I can use a graphing calculator. And then we can sort of do it another way. I'm sorry, when I say graph calculator, I mean like a Desmos tool. You couldn't use a regular graph calculator for this. But if you had to do it by hand, you have to complete the square. So I assume that's what we should do to complete this.
Yeah, because my teacher doesn't give us Desmos.
So what the first thing here is to group all the X terms, leave a space, group all the Y terms, leave a space, and then add the 11 to the other side of the equation.
Okay.
All right, so now I'm going to add in a couple of boxes here. This box is for X. This box is for also for X. And I'm going to put a blue box here and a blue box here. We're going to fill numbers into those boxes, but we're going to get to that here in a moment. All right, so when you look at the X squared plus 4X, there's an algorithm here. You take the 4, the positive 4, and you divide it by 2, and this becomes X plus 4 in parentheses. I'm sorry, X plus 2 in parentheses. Boy, that's bad. Gosh, okay. Then the number that goes in the box is the square of 2. The square of 2, which is plus 4. That means you're going to put a plus 4 over here to the right also. Now we're going to do the same thing for Y now. We're going to take this -2 and divide it by 2. Y minus 1 squared. And then we're going to square the -1 and put it in the blue box. Plus 1, plus 1. Is that okay?
Yeah. Would that give us the center?
It does.
Okay.
And then similarly here, we're going to add the numbers on the right. 11 plus 4 plus 1 is 16. And I'll just kind of rewrite it, condensing it, a little better spacing. Okay, so from here, you have to be able to determine the center and the radius you just mentioned. It's like going backwards.
So the radius is 4
Agreed.
and the center is, wait,
Yeah, take a look at a previous problem because it's really easy to get the wrong sign.
the center is 1. I mean, it's -2, 1.
Yes, got it. Good job on that. It's really easy to get the wrong sign. That's really well done. So the completing the square, you might check and see if that actually is going to be covered. We got a couple minutes left. We could do another example. Up to you.
I think I feel pretty good about this stuff.
Great. All right, we'll go ahead and stop right here.